Hello students, welcome back to my channel. Today I have picked around 4 questions from gravitation and rotational dynamics. These questions were asked in the second shift or the afternoon shift of 24th January 2023 JEE Mains exam. So let us start discussing one by one. The first question is, if the distance of the earth from sun is this much, then the distance of an imaginary planet from sun if its period of revolution is. So here what you have to understand that this question is based on purely Kepler's third law. Kepler's third law. For Earth, the period of revolution is 1 year. Okay. Right. Second thing, a small observation can drastically, simplify the solving of the question. This is actually 2 root 2, you can see, because root 2 is after all 1.414. So when you multiply 2 with this, you get this. Simple observation. Right. So according to Kepler's third law, according to Kepler's third law, T square is proportional to R cube. T is the period of revolution. R is the what? R is the distance of the planet from the sun. So therefore, we have to find the R value of R for the other planet. So I can write R2 by R1. R1 corresponds to Earth will be equal to T2 by T of Earth. Okay. So R2 upon RE. I'll substitute RE later, don't worry. So for this it is 2 root 2 years, whereas for Earth it is 1 year. Now if you extract the square root, if you extract this, if you extract the cube root, you get this. So therefore the required distance is twice the distance of Earth from the Sun. So when you double it, you get 3 into 10 power 6. 1.5 can written as 3 by 2. Okay. So 2 gets cancelled here and finally we are left with this third option. Let us move to the next question. Question number 2. Given below are two statements. Acceleration due to gravity decreases as you go up or down from the Earth's surface. This is true in fact. If you draw the graph, if you look at the graph, then you will realize that in fact acceleration due to gravity reduces as we go up or down, isn't it? See here, when it is at a distance r, where r is the radius of Earth, the value of g is maximum. Here it will be inside it varies linearly, whereas outside it varies as inverse square law. So you can see as we move from the surface inside or outside, the value of g will reduce. So statement 1 is correct. Statement 1 is correct. Now coming to statement 2, in fact this I can write it as g dash is equal to g on the Earth's surface into 1 minus depth upon radius, and here it will be g dash is equal to g into capital R by small r whole square, where capital R is the distance. Now the second statement is acceleration due to gravity is same at a height h and depth d from the Earth's surface, where h is equal to d. So this is wrong in fact. For example, if you equate these two, certainly you will not get d equal to h. H means here r plus h. This is height h. So when you substitute small r equal to capital R plus h, you will not get this. So therefore, statement 2 is incorrect. Okay. You can just by looking at the graph also you can see that the variation of the pattern of variation for G is different when you go inside the earth and when you go outside the surface. So certainly the value of G will not be same for equal H and D values. Okay. You have to equate these two and you have to check that H will not be equal to R. So that means correct option will be what? Statement 1 is correct but statement 2 is incorrect. So third option is the correct answer. Third option. Let us move to the next question, please. A uniform cylinder with radius r and length L has moment of inertia I1 about the axis of cylinder. A concentric solid cylinder of radius r dash equal to r by 2 and L dash equal to L by 2 is carved out of the original cylinder. If I2 is the moment of inertia of the carved out portion, I1 by 2. It is based on the formula, okay, for moment of inertia of a what? Solid cylinder. Moment of inertia of a solid cylinder about its axis is mr square by 2. It is just like a disk, isn't it? As far as the mass distribution is concerned, it is very much similar to a disk. So you can always use this formula. So about this axis. In fact, it is independent of length. It is independent of length. So moment of inertia is simply mr square by 2 about this axis. Okay. Now mass can be written as volume into density. So volume is pi r square L into density. In other words, I will be proportional to r to the power 4 into L. Okay. So as per the question, I1 by I2 will be r by r dash whole power 4 into L by L dash whole power 4. So this will be 2 and sorry, and this will also be 2. So this is 2 power 5, that is 32. So 32 is the answer. Okay. Now here you see I have substituted r dash as r by 2. So 2 will go up. Here L dash I have substituted as L by 2. L gets cancelled, 2 goes up. So this we get. Then the fourth question. A spherical ball of radius 1 mm and density this much is dropped in glycerin or coefficient of viscosity this much and density this much. Viscous force on the ball when it attains a constant velocity is this value of x is. Now students, you see when a ball attains terminal velocity, the net forces will balance each other. That is, there will be no net force. Net force will be 0. Now if you draw the free body diagram, you have weight acting vertically down, force of upthrust acting vertically up, and the viscous force acting up because it is coming down. Viscous force is always opposite to the direction of velocity. So velocity being in the downward direction, viscous force will be up. Now if we balance the forces, because when terminal velocity is attained, total forces will balance each other. In that case, the viscous force, as you can see, is nothing but weight minus force of upthrust. Okay. Suppose I take the density as rho for the sphere, whereas density of the background medium as sigma. So for mass we have, if V is the volume, V into rho, whereas here it will be V into sigma G. This is as per Archimedes principle. As per Archimedes principle I have written this. because force of upthrust is nothing but the weight of fluid displaced by the body. So since it's a spherical ball of radius 1 mm, I can write this as 4 by 3 pi r cube rho minus sigma into g. Now it's just a matter of substitution of values. Go on substituting the values. 4 by 3 into 3.14, radius is 1 mm, so milli means 10 power minus 3. This is density of the body, I mean sphere, is what? 10.5 gram per cc, whereas density of the fluid is 1.5 gram per cc. Remember, we are proceeding in SI unit, so convert this into kg per meter cube by multiplying by 1000. So this will be 4 by 3 into 3.14 into 10.5 minus 1.5 is 9 into 10 power minus 6. Now here students is small piece of advice. What is that advice? No need to calculate and waste time, because calculation always involves wastage of time, you know. So as a rule, you should always try to save as much time as possible. Now what they're telling, they're already, they have given the value as 3696. So maybe close to around 3700 or even 4000, not a problem. So just express the value roughly in 4 digits, and then the power of 10 will give you the value of x. Are you getting the point? Try to express the value in terms of 4 digits, that is in thousands. Thousands. Don't go into the actual calculations. And the power of 10, what will be the negative power of 10? That will be the x. So here, roughly what I'll do is, you see here, 4th is a 12, 12th is a 36 something, 37 something like that. Okay, into 10 power minus 6. Is it? 3 is a 9 minus 3. Is it correct? I think we have gone somewhere wrong in calculations, I think. Sorry, I have missed G. Yeah, I have missed G here. G is 9.8. You can take it as 10, not a problem. So here it will be around 370 into 10 power minus 6. Just add another 0. That is, you have multiplied by 10. So finally divide by 10. So this 4 digits. So the value of x is 7, you can say. The value of x is 7. So this is how you are supposed to proceed. If you are not supposed to calculate the value and check it whether it is 3696 is there or not, it has to be there, because anyway they have given. Isn't? That's all for in this video. If you have liked my way of teaching, please subscribe to my channel and hit the like button. Also share with your friends and family. Thank you so much.